In the last video, we looked at solving quadratic equations either by square rooting both sides or factoring. It's not always possible to solve quadratics by using either of those methods. What we're going to do in this video is look at an alternative method. This is called completing the square. Some quadratic expressions can be written as what we call perfect squares. An example would be x squared plus 4x plus 4. We could factor this now to give x plus 2 and then x plus 2, which we could write as x plus 2 all squared. So that is said to be a perfect square. If you wanted to look at that as a visual or as visually a visual representation, we could go ahead now and draw a square and it would look something like so. So what we've got here now is the value of x. So let's put x just here. We've got the 2 just here, we've got x just here, and we've got 2 just here. So if we consider the area of each of these sections, let's just drop a perpendicular here, and then we've got one just here. The first part just here is going to be x squared, so we can put this here. So this is x squared, this is going to be 2x, this is going to be 2x, and this is going to be 4. So we can see now that this gives us x squared plus 2x, which is a 4x plus 4. The vast majority of quadratic expressions that we come across can't be written as perfect squares. So what we can do is write the expression in the form p, and then we'll have x plus q all squared plus r. This looks quite daunting at first. In reality, the vast majority of the examples we're going to look at, p is just going to be 1. So we're going to have essentially x plus q all squared plus r. If we looked at this situation graphically, we would end up having our parabola, and just putting these on, we're going to have now the coefficient of the x squared term will be 1. So we know that a would be 1. Then we're going to have now plus 4, so let's put that on, that's plus the 4x, and then we'll have plus 4. Now with this we can see that we're going to have what we call a repeated root, and that is x is equal to minus 2. We can see that it just touches now the axis in one place. So that's a perfect square and it has repeated roots. So what happens if we have an expression that we can't write as a perfect square? So let's say we had now x squared plus now 4x plus 5, and we wanted to write this in completed square form. Now, when we're completing the square, the coefficient on the x squared term needs to be 1. If it isn't, we factor it out. So when we're looking at expressions, we need to factor that out to begin with. Often with your equations, you just divide through by the value, the coefficient in front of the x squared, and deal with it that way. So if I look at this now, this is in the form ax squared plus bx plus c. So we've got now a is equal to 1, we've got b is equal to positive 4, and we've got c is equal to positive 5. What we do when we complete the square is take half the coefficient of the x term. I open a bracket, I take x in, I add to it now half the coefficient of the x term, which is going to be 2. I then square this bracket. I now subtract away this number squared. So I'm going to subtract away now the 4, and I'm going to add the 5 that I had. So in completed square form, I've got x plus 2 all squared plus 1. Now if we look at what we've got here, essentially that's what we've got. We've got x squared plus 4x plus 4 plus 1. So we've got the completed square and we've got our perfect square and then something added on. So if we wanted to write down the values of p, q and r, we could say that p was going to be equal to 1. We could say that q was going to be equal to 2, and we could say that r was going to be equal to 1. So if you wanted this now as a visual representation, we've got the perfect square which we've created, and then this additional value. And again, that could be positive or negative. There are a fair few advantages of using the completed square method. It's quite quick to solve equations. We can also look at this graphically and find what we call maximum and minimum points, and we'll do that shortly. And we can also look to see if we've got real roots to equations. So let's go ahead now and look at an example of completing the square to solve. So what I might want to do is solve this equation right here. So let's take x squared minus 2x minus 8 is equal to 0. And we met an equation very similar to this before. So if I went ahead and factored this, let's factor this, that's going to give me x minus 4, and then we're going to have now x plus 2 is equal to 0. So I can factor this one. I'm choosing this particular one so we can kind of guide ourselves to the roots of the equation that we want. So if we look at this, we'll get x squared, we'll get plus 2x, we'll get minus 4x, and then we'll get minus 8. So x would be equal to either 4 or x would be equal to minus 2. So what we're going to do is complete the square to solve. So what I want now is a completed square form. So we write now x, we take half the coefficient of the x term. This is in the correct form, ax squared plus bx plus c is equal to 0. So that's going to be minus 1. I square the bracket and I subtract away this number squared, which is minus 1, and I've now got minus 8, and that's equal to 0. At this stage, many people might want to add the 8 to both sides. So what they might do here is x squared minus 2x is equal to 8, and then just deal with the completed square here. I personally prefer to keep it here because this holds for expressions as well. So at the moment, I'm simply solving an equation. I just like to keep it now as a completed square form on now the left-hand side and work with it from there. So what we can see then is x minus 1 all squared, and now adding the 1 and the 8 to both sides, we're going to have 9. Square root in both sides, x minus 1 will be equal to plus or minus the square root of 9. And then we've got now adding the 1 to both sides, x is equal to 1 plus or minus the square root of 9, which is 3. So if we do 1 plus 3, then we're going to end up with x is equal to 4. If we do 1 minus 3, we're going to have x is equal to minus 2. And we can see now those solutions. So if we looked at this now in the form p, and we have the quantity x plus q all squared plus r, this is the expression. I've used it to solve, but we could write this now as p would be equal to 1. We can see that just here. We could see now that q would be equal to minus 1, and r just here would be equal to minus 9. So we've got that now in completed square form. What I want to do is just pick up this point right here and write this as an expression. So if we were not asked to solve, remember an expression doesn't have a solution. We can evaluate an expression if we're given a value of x, but essentially now this is just an expression. In completed square form, we can easily graph this. This gives us now two transformations. The transformations now are two translations. We move 1 to the right and we move 9 down. So if we look at this now, and I look at this graphically, in completed square form, we've got the following. We've got now x squared, and we had minus, let's put this on, let's just check what our equation was, minus 2x minus 8. So minus 2x, and we'll put that there, and then we had minus 8, which is like so. So this now is our quadratic equation. So the red one just here is what we looked at in the last video. What I'm now going to do is put this in completed square form. Now if we look at the completed square form, we've got x minus 1 all squared minus 9. So I'm going to put now p is 1, we've got q is going to be, and they've put it down, so I'm going to have q as 1. We've got a negative in here. We could of course change that if we want. Let's change that to a plus. So if we change that to a plus, let's go and put that in. There we go. Then we can put in the minus 1. Okay, to keep this consistent, let's do that. There we go. So we can have minus 1, and then we are going to have, now let's put that, there we go. Then we need to do minus 9. Let's put minus 9 on there. And we can see now that that is on top of the other graph. They're exactly the same thing. So in completed square form, we could write this now instead of the expression x squared minus 2x minus 8 as x minus 1 all squared minus 9. So what we can see from this now, if we look, is a minimum point to the graph. Now if we come down here, that is at the point 1 comma minus 9. And in completed square form, we can see that vertex. This is called a vertex, and because the parabola is opening upwards, we see it to be a minimum point. We also have an axis of symmetry, and that axis of symmetry is right here, and that's the line x is equal to 1. So it's symmetric about that point. So we can see straight away that if we were asked to graph the equation, it would be a lot easier in completed square form. So this is an expression, this is solving an equation. Let's go ahead and look at some other examples. Let's look at writing now, and let's take x squared. So we've got x squared plus 8x, and we want to express this now in completed square form. So this isn't an equation, it's just now an expression. So if we have this now, what I could do is take half the coefficient. I've got no c term. If you like, you could add 0 on. So I'll have x plus 4. I square the bracket, and I subtract away the 4 squared, which is minus 16. So in completed square form, p will be equal to 1, q will be equal to 4, and then r will be equal to minus 16. So I've just put that in completed square form. Now, if we wanted to solve the equation x squared plus 8x is equal to 0, we could use this method, but quite clearly that factors to x plus 8, which would give us now that x was equal to 0, or x would be equal to minus 8. I could, of course, just set my completed square form to 0, add 16 to both sides, so I'd have x plus 4 all squared is equal to 16, square root in both sides, x plus 4 is equal to plus or minus, remember we're going to get a positive and negative answer, the root of 16, x plus 4 is equal to plus or minus 4, and you can see from there that we're either going to get minus 8 or we're going to end up with 0. The advantage of this, again, the completed square form, is that if I wanted to graph now y is equal to x squared plus 8x, I now have some idea on how to do this. So let's go ahead and do that. We can see now that if I wanted to show the minimum point, I'm going 4 to the left. So whatever the value is in here, we're going in the opposite direction. And if you've done any graph transformations, that should make sense. So we're going left 4 and we're going down 16. So we could say left 4, down 16. So let's put that point just there, and this would be the minimum point. So we could put now this point right here, and this would be minus 4, minus 16. And then, of course, all we would do is simply now draw this. So our axis of symmetry would be the line x is equal to minus 4. So let's just put that on. That's going to look something like so, and then we would be symmetric about that point. So let's go ahead and do that. So that is a minimum, and the reason it's a minimum, and we'll come back round this way, let's just do that. The reason that's a minimum now instead of a maximum is that we have now a positive quadratic equation. So nice and straightforward and nice and logical. Let's now try another one. Let's go for, and we'll solve this one. Let's solve x squared plus 5x is equal to, let's go for that's going to be equal now to, we'll go for now minus, let's say that's going to be minus 4. So can we solve this equation? Well, let's have a look, see what we can do with it. What I need to do is consider taking half the coefficient of now the x term, and that's going to be x plus 5 over 2. Don't write it as 2.5, as if we square 2.5, that's going to give us 6.25, and you can see it's going to get messy. When we're dealing with these non-calculator problems, it's always better to work with fractions. So what I'm now going to do is square this. I need to subtract away this number squared, which is going to give me now minus 25 over 4. And that's going to be equal to minus, and we've got minus 4. And I'm just going to write this as minus 16 over 4. Now, why have I done that? The reason I've done that is so that when I add the 25 over 4 to both sides, then we end up now with the same denominator, and it makes our life slightly easier. So adding the 25 over 4 to both sides, x plus 5 over 2 all squared will be equal to, so what I'm going to do is add now the 25 over 4 to the minus 16 over 4. If I do that, I'm going to end up with positive 9 over 4. So let's go ahead and write that. Now at this stage we can see that this is going to give us real roots. If that number on the right hand side was a negative, it's not going to give us real roots, as if we try and square root a negative number, we don't get real solutions. So let's square root both sides. X plus 5 over 2 is going to be equal to plus or minus the square root of 9 over 4, which is going to give me 3 over 2. If I square root 9, I get 3. If I square root 4, I get 2. So what I'm going to have is x will be equal to minus 5 over 2. And all I'm doing is subtracting 5 over 2 from both sides, plus or minus 3 over 2. So consider what I've got. Now if we look at this right here, what I'm going to do is just rewrite this. X squared plus 5x plus 4 is equal to 0. X plus 1 multiplied by x plus 4 is equal to 0. So we can see that x would be equal to minus 1 or x would be equal to minus 4. If we look at this right now, if we take this to be the positive value, we can see that I'm going to end up on here. Let's just check those. I'm going to end up adding these two fractions. So if I take this to be minus 3 over 2 and then I subtract that away, I'm going to get minus 8 over 2, which is minus 4. And then if I take it now to be the positive 3 over 2 and subtract away, I'm going to end up with minus 2 over 2, which is the minus 1. So you can see that even if you complete the square accidentally, you can see that it gives the same result. So this now is completed square form. If you wanted to go ahead and simply graph this, you would now have a minimum point to go from. Okay, let's look now at another example. Let's say we were asked to express minus x squared plus 4x minus 14 in completed square form. So I'm looking for the form p, and then we're going to have x plus q all squared plus r. So I'm not solving an equation. I personally think this would be easier if we were solving an equation, because we could simply now move everything over to one side, set it to 0 and have a positive term. When we're completing the square, we need to ensure that the coefficient in front of the x squared term is just 1. So what we want then is the following. We want to factor out minus 1 from this. So what I'm going to do is take out minus 1. I'm going to open up square brackets, and I'm going to have x squared minus 4x. And now at this stage, some people will leave the minus 14 out. I actually like to take it inside. I'm going to give you the option of whether you want to do that. It's entirely up to you. If I do, this will become plus 14. You can leave it outside. All I'm going to do at this stage is complete the square within the square brackets. So I've got now minus, so minus 1 on the outside. I've got x minus 2. I'm taking half the coefficient. So I've got x minus 2 all squared minus 4. I've squared the number and subtracted away plus the 14. So I've got now minus, and then inside this bracket I've got x minus 2 all squared plus, now I've got minus 4 plus 14, which is plus 10. So I could write this now as minus the quantity x minus 2 all squared minus 10. So this is in completed square form. If I wanted to graph this now, I could, and this will give us a really clear picture of what this graph would look like. And the reason this is an advantage is now that we can see that this is going to be a negative quadratic. So we're going to get a maximum point instead of a minimum point. So let's go ahead and graph this one. So p is going to be minus 1. We've got now on here the value of q in the bracket is going to be minus 2. So let's get minus 2. So let's get, there we go, minus 2. And then finally we've got the value of r to be minus 10. So let's put minus 10 on. It'll just give me enough. There we go. Okay, now let's have a look at this graph here. This is what we end up with. Now, if I just scroll up, let's do that. Let's just grab that. In fact, we need to scroll down. Well, I don't know why I'm scrolling up. And we'll just scroll out a little. That's what I want to do. So we can see now that the axis of symmetry is just here. And that's the line x is equal to 2. So if we go back to our bracket now, we can see that that gives us the 2 in there. So this now is a translation of 2 minus 10. we've also got now the reflection, and that's what's given us this minus value. So if you've ever done any graph transformations and wonder how these are formed, you're essentially taking the x squared graph and you're performing different transformations. So this is our quadratic here. Let's just move that up, and we can see from this now that we're opening downwards. So the question is, at this stage, would this now have any real solutions? We can see graphically from here that that is not going to cross the x-axis. Therefore, we can see that it's got no real solutions. Now, if we'd set this equal to 0, so if we set it equal to 0, let's go ahead and do that. What we could write now is the following. We could write that minus 10 is equal to, and adding this to both sides, just to make that slightly easier, x minus 2 all squared. Now, if I try and find real solutions at this point, I'm going to try and square root a negative number. And as you know from doing maths before, you don't get a real value. So if I try and take the square root of negative 10, this will give us a math error. So there we go. So we can see straight away from the completed square form that we can quickly establish whether we have real solutions. Okay, let's look at solving another quadratic equation using the completed square form. So what we're going to do is take 2x squared, so 2x squared plus 11x minus 4 is equal to 0. Now, at this stage, you might want to add the 4 to both sides. I'm being really quite open in terms of the way that you deal with this. I'm solving an equation here, and we complete the square only when the coefficient of the x squared term is 1. So if I wanted to solve this, all I'm going to do is divide both sides of the equation by 2. So I get x squared plus 11 over 2x minus 2 is equal to 0. So if you want to add the 2 at this stage, you're more than welcome to do so. So let's complete the square here. X plus 11 over 4. If I take half of 11 over 2, that's 11 over 4. Don't be tempted to put 5.5 over 2. As you can see, that's going to get very messy. We square this. We subtract away this number squared. 11 squared is 121. We've got 4 squared, which is 16. Right here, I've got now minus 2. Now 2 over 16, if I put 2 into 16, I'm going to have 32 over 16. So from here, I've got now x plus 11 over 4, all squared, will be equal to 153 over 16. So I've simply added those two fractions together and put them on the other side. So to solve, we'll take the square root. So x plus 11 over 4 will be equal to plus or minus, let's put an equals rather than just plus or minus the square root of this value. Now the root of 153, that's not going to break down, so that's going to be an exact value. So the root, so plus or minus the root of 153 over the root of 16, which is going to give me 4. So what we've got now is x will be equal now to minus 11 over 4 plus or minus the square root of 153 over 4. These are what we call exact values. I've left this in third form, so that's an exact value. So what we have is x is equal to minus 11 plus or minus the square root of 153 over 4. Now, the square root of 144 is 12, the square root of 169 is 13, so that's going to be somewhere in between. So let's say that's going to be about, let's just say 12.5. So if we wanted, we could go ahead now and look at this. Now, I can put on the rough roots of this equation. So what we've got then is minus 11 plus 12 over 4. So let's put that on. So if I have minus 11 plus 12 over 4, that's going to be somewhere around here. And I can put that on. Let's put minus 11 plus the root of 153 over 4. And then I'm going to have some other solution down here, which is going to be minus 11 minus the square root of 153 over 4. So what we end up then with is something that looks like so. So we've got this quadratic, and it'll do something like that. So that's what we end up with. Now that's to solve. If I was just asked to complete the square with this, and it wasn't an equation, and it was just simply an expression, I would take a slightly different approach, as I can't divide through an equation by 2, as I've just got an expression. So what we might be asked to do is write 2x squared plus 11x minus 4. So that's what we had. That's what we've got just here. And now just write this in the form, and we've got P, the quantity x plus q, all squared plus r. So this is no longer an equation. I've not got it set equal to something, so I can't divide through. So what I'm going to do is take out the 2. When we're completing the square, the coefficient of the x squared term needs to be 1. So I've got in the bracket x squared plus 11 over 2x minus 2. And again, you can argue whether you take that minus 4 in or not. So what I'm going to do is complete the square inside the brackets. So I'm going to have 2 lots of the quantity now, x plus 11 over 4. So I've taken half the coefficient. I'm going to square this. I've got minus 121 over 16. And now I've got minus my 32 over 16. So you could probably argue, well, I don't want to do that. I want to do it at the end. You're still going to essentially have to add 2 fractions with different denominators. So that's what I've got. At this stage, I'm going to multiply back through the by the 2. So I've got 2 lots of the quantity x plus 11 over 4 all squared. Now this is going to give me minus 153 over 16. So it's going to be minus 153 over 8, as I'm going to multiply through by the 2. So that is in completed square form. So whilst we use this to solve for an equation, in completed square form, it's slightly different. And we can see that if you need an expression, we can't divide by 2. And this obviously has implications for showing now the minimum point on here. But hopefully that makes sense. So all we've done now is taken half the coefficient inside these brackets and express this. So we would say that P would be equal to 2. We would have Q equal to positive 11 over 4, and then R would be equal to minus 153 over 8. So that's using completed square form. Let's look at a couple more. Let's say we had now, let's go for, we're going to have 1/2, let's write 1/2 x squared, and then we'll have plus 4x, and then we'll have plus 5. And we would be asked to complete the square now in the form p x plus q all squared plus r. Now, sometimes it won't be written in this form. You might have a x plus b all squared plus c. All p, q, and r, or a, b, and c are constants to be found. So can't yet complete the square, so we're going to take this out. So let's take out the 1/2. That's going to leave me x squared plus 8x plus 10. So just check that we've got that right. If we've taken half out, I need to double this term and double this term. So we're going to have half, and then we'll have now x plus 4. I'm taking half the coefficient. I'm now going to subtract away 4 squared, which is minus 16, plus the 10. So that's going to give me now 1/2, so multiplying back through, 1/2 the quantity x plus 4 all squared. Here now I've got minus 4, so I've got minus 6. So minus 6 divided by 2 is going to give me minus 3. So that is in completed square form. So all I've done is essentially rewritten that and just written it as a, the quantity x plus b all squared plus c. So that is now an expression. If you wanted to solve this as an equation and it was set to 0 at this stage, add 3, multiply both sides by 2, square root both sides, and then subtract the 4. Okay, let's look at another one. In this one, I think we'll do something different. Let's look at something different. Let's say we've got now 3x squared plus 6x minus 4. And what we're going to be given is an identity. So with an identity, it holds true for all values. What we're going to look at doing is finding the values of p, q, and r such that this holds true. So you might be asked to find the values of p, q, and r. This is an alternative way to complete the square. I don't suggest you have to do it, but it's a nice thing to think about. So if you wanted, you just go ahead and complete the square. Alternatively, we could compare coefficients. Now, what I'm going to do is expand this out. So what I'm going to have here is the following. P, if I expand this, I'm going to have x squared, and then I have 2xq, or qx, and then plus q squared, and then we will have plus r. So what I'm now going to do is look at the terms in x squared. So if I just write this out, terms in x squared. So on the left hand side of the identity, I've got 3x squared, and that's going to be equal to, the only thing that's going to give me a term in x squared is going to be p. If we now look at terms in x, on the left hand side I've got positive 6x, and then on the right hand side I've got 2pqx, so I've got 2pq. If I now look at the constants are the terms without an x squared, so let's put that without an x, minus 4 on the left, and then on the right hand side we've got pq squared plus r. So we've got pq squared and then we've got plus r. Now we can see from here that p is going to be equal to 3. So p is equal to 3. If I substitute this in now, what I've got in this particular equation, 6 is equal to 2 times by 3 times by q, so that's going to give me 6q. I've just subbed in p as 3, therefore we can say that q is going to be equal to 1. If we look at this now, we've got minus 4 is equal to pq squared, so that's going to be p multiplied by 1 squared, which is 3, and then we're going to have plus r. So subtracting the 3 from both sides, we've got r would be equal to minus 7. So in completed square form, we could write this now as 1, and quite clearly we wouldn't leave that in. Then we've got now the value of q. The value of q is going to be now 1, and then we're going to have on the, p is going to be, my apologies, p is going to be 3. So let's just put that back. P is going to be 3, I've just worked p out. Then we've got q to be 1, and we've got r to be minus 7. So we've got squared minus 7. And that now is in completed square form. So by using an identity, we've just expanded it out and used an equated coefficients. Now, if you wanted to do that the normal way, let's just check that that works. So let's take now our values, and we've got 3x squared, what was it, plus 6x minus 4. Let's say we wanted to go ahead and complete the square on this. Let's do it the normal way. So we can't complete the square until this term is just 1. So we'll take the 3 out, and then we'll have now x squared plus 2x. And again, if you don't want to take this in with you, you don't have to. We're going to have minus 4 over 3. So all I've done now is divided through by 3. So we'll have 3, and then we will have x plus 1 all squared minus 1. Now at this stage what I'm going to do is write this now as minus 3 over 3. Minus the 4 over 3. So all I've done is subtracted 1 away. And I've just written it in the same denominator here. So entirely up to you. So what I've got then is 3 lots of the quantity x plus 1 all squared minus 7 over 3. Now of course when we multiply back through, we're going to have 3 lots of x plus 1 all squared minus 7, and we can see exactly the same way. So this is an alternative method. 3, the quantity x plus 1 all squared minus 7 can be found in both ways. So there we go, completed square form. We've seen some of the advantages in terms of finding maximum or minimum points, that is the vertex of a graph. We've looked at the axis of symmetry, we've looked at finding solutions or the roots of equations, and this is used when quadratics don't factor. The vast majority of quadratics won't factor, and this is a nice way to do it. What we're going to do is just finish off by looking at the quadratic equation. Now the quadratic equation, the solutions, the roots of a quadratic equation are given to be x is equal to minus b plus or minus the square root of b squared minus 4ac. And this now is all over 2a. And this is when we have a quadratic in the form ax squared plus bx plus c is equal to 0. Now, when you use a quadratic equation, you simply plug numbers in, and you're often given this. For example, if you've done maths lower down the school, you're given that equation. If a quadratic is in this form, here's how we solve it. What we're going to do is look at using the completed square form to derive the quadratic equation. So let's take this right here, okay? This is what I've got. So this is where I'm going to start. I've got ax squared plus bx plus c is equal to 0. Now this is an equation, so if I'm completing the square, I want the coefficient on the x squared term to be equal to 1. So I'm just going to divide the whole equation by a. So I have x squared plus b over a plus c over a is equal to 0. I'm now going to complete the square. So I take x, let's just put the x there, my apologies, I've got b over ax plus c over a. I take half the coefficient of the x term, so I've got x plus b over 2a. I square this. I now need to subtract away this squared, and that's going to be minus b squared over 2a all squared, which is 4a squared. Now I've got plus c over a, and that's going to be equal to 0. At this stage, I'm going to get a common denominator on these two. Now the common denominator is 4a squared. So I need to multiply this fraction by 4a to get a common denominator. So what I'm going to have is x plus b over 2a all squared, and then we're going to have minus b squared over 4a squared, and now I'm going to add to this. So what I want to do is now multiply this by the lowest common multiple. The lowest common multiple is going to be the 4a squared, so I need to multiply this by 4a. So it'll be 4ac over 4a squared, and that's going to be equal to 0. So x plus b over 2a all squared will be equal now, and I'm going to add the b squared over 4a squared to both sides and subtract this. That's going to give me now b squared minus 4ac all over this common denominator now of 4a squared. At this stage, I want to square root both sides of the equation. So x plus b over 2a will be equal to plus or minus the square root of b squared minus 4ac over the square root of 4a squared, which is just going to be 2a. Now I'm going to subtract b over 2a from both sides. So x is equal to minus b over 2a plus or minus the square root of b squared minus 4ac, let's write this in, 4ac, all over 2a. We've already got a common denominator, so we can just combine that. So we've got minus b plus or minus the square root of b squared minus 4ac all over 2a. So we've completed the square to derive the quadratic equation. So if the quadratic's in the form ax squared plus bx plus c, and you've been given this quadratic equation before, that is how we can derive it from a completed square form. So there we go. I don't think you're going to be asked to show that in an exam, but I don't see it to be a huge issue. As remember, these values of a, b and c are just constants. They're not changing. The variable, the thing that's changing in this particular case, is the value of x. So in the next video, we're going to go on and use the quadratic equation to solve quadratics. I personally prefer to use completed square form. I think it's a lot quicker and a lot easier, but you do have the option a lot of the time.